Previously, we have looked into performing F-test to determine which specific test we do if we are to compare two independent samples. Now, if the F-test did say that the two variances are not equal, the next requirement is that both samples should be greater than or equal to 30, which, as we all know, is one of the requirements from the central limit theorem for us to assume that these samples are from or at least approximately normally distributed. So once we have unequal variances and both of the sample sizes are greater than 30, then we can use z-test. So because of the z-test being from the normal distribution. So now let's use Microsoft Excel for us to be able to perform a z-test for two sample of means. Alright, so let's go back to this example that although their means are actually, the variances are actually equal, their sample sizes are still greater than 30, which is actually enough for us to use z-test for this too. That is actually enough. Whether or not the variances are equal or not, once these are greater than 30, then z-test can be used. Although later I'm going to explain the other test, which is also okay for bigger or for sample sizes of this size. So we're now going to use z-test. Maybe let me just change the location of this. So now let's go to data analysis to perform z-test. Scroll down, you see this here. Z-test to sample for means. So we click OK. Now in z-test we are not that much concerned which is variable 1 and variable 2. For consistency's purposes, let's just continue using female as our variable 1. Although you can already use male for variable 1, but let's just consistent variable 2. There you go. Now, the first thing that's quite different from F-test is that there is what we call the hypothesized mean difference. This hypothesized mean difference is if there is something stated in the problem that the difference between the two samples is something specific. So if we go back to the problem, there you go. It just says that the means are different. There is no, the mean is greater than the one for the female. There is no such claim how much greater. So we're just going to leave this blank. Now, for the variance, for variable 1 and variable 2 of the variance, we have already computed it here. So, since it doesn't have that button there, we need to actually type. So for variable 1, since that is female, so we're going to input 10.6698. For variable 2, that's male, 10.6188. Then again, I selected the label, so we input the labels. Alpha is 0.10, so we change this to 0.10. Then the output range, there you go. The output range, I'm just going to select it here. So when you're good with everything, click OK, and there you go. Now that we have this table already provides steps 2 and 3 of our hypothesis. So what we need now is steps 1 and 4. So steps 1 and 4 in the p-value approach is still the same. So for step 1, what we need is HO and HA. And we usually get this from our claim. Oops, let's just write HO and HA. So according to this, the hypothesis or the claim is that the number of spores, Let's use that. So the average number of sports that colleges offer for males is greater than the average number of sports that colleges offer for females. So the average for male, we're going to write that down, the average for male is greater than the average for female. So that is the claim, and it says greater than. There's no equality there. That is for our HA. Mean for the male is greater than the mean for the female. That means for the null, the mean of the male is less than or equal to the mean of the female, making this a one-tail upper tail test. So that is important because as you can see here, let's just a little bit. We have two p-values, one for one tail and one for two tail, just like we have different c values for one tail and then critical values for one tail and then two tail. So as you can see here, we almost have the same. We computed the mean here. We have the known variance and then the observations. Since this is a z-test, there is no degrees of freedom needed. The hypothesized mean, since there's none, it just says 1 is greater than 0. So this is the test statistic. But since we're going to use the p-value approach, we either choose this p-value or this p-value. But according to this, if it's one tail upper tail, we need to choose this p-value. So steps 2 and 3, the computation of the test statistic, which is the basis of the p-value, and the computation of the p-value itself is already in this table. So we now go to the last step. So based again from the universal decision rule for p-value method, if the p-value is less than or equal to alpha, we reject HO. Since we are going to use one tail, the p-value is 0.17101. What is that compared to the alpha of 0.10? As we can see, this is greater. Therefore, we have failed to reject our null hypothesis. Hence, our conclusion would be there is no there's no sufficient evidence to reject HO. Thus, the mean of the males is less than or equal to the mean of the females. And that is one example of performing z-test to sample for variances. Let's have another example here. Let's clear this up. There you go. We mentioned, this is already one thing that we did already for f-test. Now let's use this for z-test because as you can see, although their means are equal, the sample sizes is greater than 30. So pause the video and try to see what results we'll get. Perform a full hypothesis test for this example. Alright, so assuming that you did that, let's first, although you can do for step 1, then do the data analysis part. I'll do first the data analysis part so we can immediately go to the other steps of the hypothesis test. So data analysis there, test. Just to be consistent with what we did already, I'm going to select Europe as our variable 1. Although again, you may select US as your variable 1. There's nothing wrong with that, since this is a z-test. Then the hypothesized mean, we have to be extra careful. For Europe, that would be 224,795. One for US, 202,383. The alpha is 0.01, not 0.1, but 0.01. And the output range, I'll better place it here. There you go. So we have this one here, and now just perform our steps. So step 1, we have our HO and HA. So, the claim that we have here was to see if the average length of the major rivers in the United States is the same as the average length of the major rivers in Europe. So, it's the same. So, if it's the same, then that's equal. Average of US is equal to the average of Europe. I'll just use U and V. So with that in mind, so that's equality, that's not. So the mean of the US is equal to the mean of the Europe. HA therefore will tell us that the mean for the US is not equal for the mean for Europe, making this a two-tailed test. Thus, we have our steps 2 and 3 here. We're going to select this one here. Let's just make this a bit bigger so we start it. If you double click that, it will actually there. So, but what we wrote is called a comment. So, it's not, there you go. Two-tailed. So, this is what we are going to actually use. So, based from that, the p-value of 0.39199 is what compared to the p-value of 0.01. Obviously, this is bigger. Therefore, we have failed to reject HO. Hence, the conclusion of this would be there is no sufficient evidence to reject HO. Thus, the mean length of the rivers in US is just the same as the mean length of rivers in Europe. And that is the test.